Jai Hind everyone, I am Pankaj Kumar. In today's lecture we are going to read about the nucleic acid chemistries, and basically this is a series of the lectures in which we are reading the DNA and RNA and their specifically their structure. So this is the second lecture of that series. We already covered the first lecture in which we studied the DNA structure. If you didn't watch, you can click here the link which is popping up here on the right corner. So let's begin with the today's lecture. In this lecture, what we are going to cover the denaturation of nucleic acid alteration, and the DNA methylation. So briefly, I will tell you just few words. Denaturation means what? DNA will be denatured, and how it will be reannealed, how it will annealing will be occur, and how much time it will be take. What are the factors will affect it, that we are going to see. So nucleic acid alteration we are going to read. Alteration means what? The nucleic acid have a either maybe because of UV rays it will be damaged, because of the alkylating agent, or because of the uh, any nitrous oxide. These things will nitrous acid will be damaging the DNA or other kinds we are going to see. And basically it will DNA alteration will cause the mutation that we are going to read, and then DNA methylation will understand why the DNA methylation is very important. So definitely you're going to like this video. So let's begin it. So DNA naturation of the denaturation of the nucleic acid will be occur by the heating only. Okay, so not only but mostly it will be done by the heating. So you can see the DNA at the 25 degrees Celsius, at the pH, it will be negative and it will be viscous in nature. As the temperature will be increased, the DNA will start denaturing. So it's not like that it will be denatured at any temperature. There is some TM value, like melting temperature, at which the DNA double strand will be start uh, breaking. So the question is that if the temperature is increasing, will break the complete DNA like covalent bonds also, or it will break only hydrogen bonds between the new nitrogen base. So answer will be it will only denature most hydrogen bonds between the two bases initially. So at certain temperature it will break the hydrogen bonds initially only. Got it? So this is the DNA. As you can see, it is DNA, it is denaturing by heating. So this is the partial denature, and if you continue the high temperature, the DNA will be completely denatured. So what is the happening if it is partial denature, and what is happening if it is a completely denatured? So this picture is taken from the Leninger book which we are following for our studies, and that is a very nice book. You could have read, and you can follow these videos of their lecture for your preference. Now the thing is that DNA will be denatured easily if the AT-rich DNA is there. If means adenine and thymine will have two hydrogen bonds, so it will easily break. But the guanine and cytosine will have three hydrogen bonds, so it will takes time to denature. So it's obvious that three bonds will take time rather than the two bond. So GC-rich content will take more time, like will have the higher melting temperature than AT-rich. So if it is a completely denatured or it is partially denatured. So if it is a completely denatured, the first annealing time will first annealing will take time. Why? Because all the strands which is denatured here, you can see here, that will take collision, random collision will be occur, and they will try to find their complementary base, which is not easy. But in this case, the complementary base will be nearby only, because already half of the DNA is in the proper state, and it can be bind again, reanneal again, and in a fast manner. So partial denaturing will be having the fast annealing, and the complete denaturing will have the first slow annealing. About the absorbance, if you'll see, the absorbance of the DNA will be at 260 nanometer of the UV rays. So it will be absorbance will be high for the completely denature, but the absorbance of the partial denature will be low. Why? Because the compounds like nitrogenous bases which are there, it is stacked here, but here in the completely denatured, it is not stacked. So that is why the partial denature will have a low absorbance and the completely denature will have the high absorbance. So if it is a high absorbance, it will call as a hyperchromic, and it is happening mostly in the single stranded DNA, or you can see in the single stranded RNA, you can see. Or hypochromic means what? Low absorbance, in which it is actually happening in the double stranded DNA. You can see, follow this. Now nucleic acid stability will depends upon the first, it is depend upon the GC content, and second, if we'll talk about the RNA and DNA, what will be the more stable? Can you please comment in your box, chat box? So before seeing the correct answer, so we can find whether you are correct or wrong. See, the RNA duplex is more stable than the DNA duplex. Why it is? We'll see. So RNA duplex is more stable than the RNA DNA duplex, and RNA DNA duplex is more stable than the DNA duplex. It means least stable is the DNA duplex. Why we are saying? Because actually we don't know the answer. But RNA DNA duplex will have the more stacking, and it will get more stable. This is my assumption, but actual answer we don't know. So at neutral pH, the denaturation of the double helical RNA requires temperature at least 20 degree higher than the denaturation required for the uh, DNA. So nucleic acid alteration we are going to see. What is the mutation? Mutation is something which we are talking about, the change in the DNA. What is the change in the DNA? Basically, the nitrogenous basis is the only different. Otherwise, sugar is same, phosphorus is same, and phosphate is same. So what is changing? The nitrogenous base. So A, G, C, T will change. So AGCT will be changed, and because of that AGCT, it will, if there will be any change in the nitrogenous bases, then definitely it will cause a mutation. Every change will not cause a mutation until unless it will be inherited or it will be cause any physiological changes. So these things will be occurred by which the DNA will change, like damage will be occur. So either it will be deamination or alkylation, or it can be damage will be because of the UV damage or oxidative damage, or hydrolysis of the glycos and beta glycosidic bond. So deamination, let's see the deamination. In deamination, what will be happen? The cytosine will become the uracil, or uracil, and then oxygen will become the hypoxanthine, guanine will become the xanthine, and 5-methyl cytosine will become the thymine. So these are the changes which is happening, and you have to remember it because they are going to ask the question from the mutation as well. So this is the very important topic. So you can see the deaminating agent is what? The nitrous acid. Okay, nitrous acid is the deaminating agent. So anybody can, any one of you, ever you think like why this uracil is only the extra, or something which is replacing the thymine in the RNA, and thymine is replacing the uracil in the DNA. Why it is happening? Why we nature not decided to keep either thymine or uracil? So you can see the usually the cytosine is present in the DNA, and if it will be, why the uracil is not there in the DNA? Why we need a thymine extra, and nature put little hard work to give one more nitrogenous base, so we can do the same things with the uracil. So actually it's not possible because as you can see back, I will go back. The cytosine will convert into the uracil by the deamination. So cytosine deamination is like it will be once in the 10 lakh of the cysteine in 24 hours. So in a day it will be around 100 cytosine will be converted into uracil, which is more frequent than the adenine and guanine. So if it is happening like this, if cytosine will convert it into thymine, sorry, if uracil will be there in the DNA, so that uracil will be sometime it will be incorporated in the adenine. Definitely, it will be incorporated into the like complement with the adenine, and it will make a stable DNA again. But hence the DNA doesn't have a uracil, so even the cytosine will go for the mutation like deamination, which is more frequent. As you can see, 100 uh, cytosine will convert it into uracil daily basis. So there will be huge change in the DNA, and definitely we are not going to survive as a human because there will be mutation occurred with the uracil. So nature decided to like use thymine instead of the uracil. So if the cytosine will be converted into uracil by deamination, that will go for the repair mechanism and it will be easily eliminate, and it cannot bind with the adenine in case of a DNA. Got it? This is the important part. Now, alkylation will be what? Alkylation is something which we are getting alkylating the molecule like nitrogenous base again. So dimethyl sulfate is there which will alkylate this guanine tautomer and into the O6 methyl guanine. So damage because of UV rays. So UV rays is not only the damaging, but X-ray, gamma ray is also damaging. But we'll see once UV rays. So UV ray in between 200 to 400 nanometer, in which it will convert. It will like form a pyrimidine dimer, as in case of the thymine. So thymine you will see here. The thymine you can see the consecutive thymine will be forming a cyclobutane thymine dimer. So cyclobutane thymine dimer will be formed here, but the same UV ray will form 6,4 photoproduct. It is like a different between the thymine, but the bonds between different carbons. Got it? This is the uh, damage because of the UV ray. And you can see here that I will hide my camera if I can. Let me see. So as you can see here, the DNA DNA will be not in the proper double helix stage. It will little bit till you can. I cannot show here right now. Let me see if I can do. No. Okay. Sorry for that.